Hello, Dylan from Pinax here, and today I'm going to talk to you about datasets, which is a product that Pinax has been working on in the past few months. And let's get going. So, what are datasets? Well, they're just blockchain datasets representing mostly raw block activity for whatever chain you can think of. But we're basically trying to abstract away the complexity of trying to access that data in the first place if you're just a normal person or just a data analyst with not much resource at hand. So you've got the problem of data volume. Some blockchains represent hundreds of gigabytes of transfers a month, and you take that up over the years, and it just becomes tons and tons of terabytes that you, a simple user, can't manage yourself. And you've got also the extraction complexity. You could extract that data yourself, but it's really hard to just from RPC to extract that detailed structured data yourself. It's difficult. So removing that complexity. You've also got the tooling compatibility problem. Well, it's all cool, but analysts aren't really familiar with blockchain extraction tools. So if that's your domain, you don't really want to do that yourself. Got also the scalability burden. Let's say you want to analyze not one, but two, but or three or four blockchains. Well, that takes up a lot of data and it's just operationally heavy and you can't manage that yourself. You've got also the limited access question. It's difficult to create that download by blockchain data at scale. It's also the storage questions that we're talking about here. What are we doing to solve this problem with data sets? Well, what we do here is that we use Firehose and Substreams, which are streaming fast technologies. Streaming fast offers those tools so that you can just write Rust programs mainly from raw block definitions, extract whatever data you need. Here, data sets model basic raw blocks activities. So let's say for blocks, for transactions, for logs, for traces, we structure that data and we just output it in the Parquet files. So then those Parquet files, you can interact with them in many ways. First, we've got the Snowflake Marketplace offering. We basically import those Parquet files into our own Snowflake managed database. And then we can offer those databases for you to interact with on the Snowflake Marketplace. Or maybe you want to interact with those Parquet files yourself. So maybe you just want to query our S3 endpoint and to fetch the files you need. Well, that's also possible. You fetch the files you need and you use whatever you want. It can be AWS Athena, ClickHouse, Google BigQuery, or anything else. Or maybe you want to use Python data science libraries like Pandas or Polars. That's also an option. You just import away the Parquet files and you're good to go. So right now, Pinax has a couple supported chains for these data sets. We've got Ethereum in the Beacon chain being the Ethereum consensus layer chain where everything goes on to ensure the integrity of the Ethereum main chain. So that's available. We've also got a bunch of Ethereum based chains like Base, Arbitrum One, BNB Chain, Polygon. We've got the big player Solana, and we've got a couple interlope based chains like EOS Network, Wax, and Telos, with more to come. So now that you know about this datasets product, maybe you'd like to know exactly what columns they offer, what tables they offer. We've got a little website here called pinaxdatasetsdemo.vercel.app, which is a demo at this point, but you can see everything that we're working on and everything we're going to offer, and it should be updated automatically. So let's say here we want to learn about the Ethereum offer. So we can see that we have account creations, balance changes, blocks, code changes, logs, storage changes, traces, transactions. So those are all tables. So maybe I want to learn about traces. Well, here we can see that the traces schema table has 32 fields, 32 columns, and they're all pretty neatly described so that even if you're not familiar with Ethereum but want to familiarize yourself with Ethereum, this can serve as a good resource to learn about that. So let's say we quite know what we want, and maybe we want ERC20 transfers. Well, good, because we've got some sample queries here that you can copy and paste and interact with. So this will take the daily ERC20 transfers for the first week of November 2024. Let's try that. So here we've got the little SQL playground. This is the Snowflake SQL playground exactly. This is connected to our Snowflake Marketplace offerings. So whatever that you write in here should work with the Snowflake Marketplace offering we have also for that database. So let's paste what we copied. We've got the traces for the first week of November. Let's run that query. All right. And we've got our total, our daily total for the ERC20 token transfers. That's good. Maybe we want to try another one. Maybe we want to learn about EOS, DB ops, let's say. Some other descriptions. And let's see. Maybe want to know about the most frequent table modifications. Let's test that query. All right. All right, so we've got the UTXO code. So let's say you want to write your own queries. You want something specific, but you're not really a SQL pro. And let's not talk about Snowflake SQL Pro. Maybe the syntax is a little different. Well, okay. Well, let's just say that we've got the LLM component here. Let's just generate our SQL queries and the AI will take care of you. So we want to list the top 20 Ethereum most active contract addresses by transaction count in November 2024. I don't want to write that. I want AI to write that for me. Let's go. All right. You've got this query. Does it do what it says? Yeah, let's confirm Tito. Maybe let's see. Yeah, transactions. Those look like valid fields. Yeah, we've got two, so it seems to work. Let's run that query. All right. Transaction count, the contract address, ordered in descending order. So that's what we wanted. Cool. Let's run another one. Maybe want to show the Ethereum hourly number of unique active addresses compared to gas prices. Let's try this. Date trunk is used here. I wouldn't have known to use it. So that's good. Let's try. We've got the hour, we've got the unique addresses, and we've got the average gas price. Exactly what we wanted. And the last one, maybe we want to calculate the average number of EOS actions per block and transactions per block per hour by hour. Let's try that. Okay, some fancy select extract here. I would have maybe spent an hour writing that myself. So that's interesting. Let's see. Okay. First hour, which is a zero indexed, we've got 48 actions, the average. Cool. We've got it all. So that's pretty much what you can expect to do on this website. We've got this little data explorer that's very useful to quickly browse through the fields available. So if you want to write those queries manually yourself or just want to know how to write that LLM query, we've got you covered. And if you want to go straight to the documentation for a specific table, you can also read the documentation here. And it should bring you with to the place where you can see every description and the sample queries for that table. Now that you've learned about Pinax datasets, maybe you understand better why that's an interesting product for you, whether you're an analyst, a developer, or just a hobbyist trying to understand some things or trying to gain some insights into what's going on in a certain blockchain. We've got you covered. We're removing all that infrastructure complexity, that extraction complexity, that storage complexity, and you've got all these Pinax datasets available for you that you just plug and play and you write your SQL queries and play around with it, and you maybe generate some real insights for your application, for data science, or whatever you need. We've got you covered with Pinax datasets. So thanks for listening and check our little website out. Thanks.